Hello there, welcome to this video on finding the sine, cosine, and tangent values of a right triangle. This is the start of Unit 10 where we're going to look at and review right triangle trigonometry. And again, we'll review the functions sine, cosine, and tangent. Alright, so our objective is that students will be able to find sine, cosine, and tangent of an acute angle. And remember, acute, that just means less than 90 degrees. Here is a prior knowledge question asking you to find the length of side G, D. Now this is a right triangle, and if you have not worked with right triangles in a while, you'll remember that there is a special theorem that ties all of the sides together, and that is the Pythagorean Theorem. And the Pythagorean Theorem just says a squared plus b squared is equal to c squared. Now, the legs of the sides can be interchanged, doesn't matter, but c must. It must be the hypotenuse. And the hypotenuse is here. And I'll just write this down too, especially if you've forgotten this, I would write this down. The hypotenuse. The hypotenuse is always the longest side. Always, always, always. Longest side. And it is across from the right angle. Always across from the right angle. Hypotenuse. Okay, so that being said, go ahead. Pause the video. Let's see if you can find the length of side G, D. Alright, so hopefully you paused this and you went ahead and gave this a go. For this situation, again, our legs can be either A or B. So I'll go ahead and I'll just say, okay, x squared plus 7 squared, that's the other leg. This has to equal 25 squared. So there is your setup, okay? And if you went ahead and utilize the calculator, your solution should look something like this. So you have GD, or x squared plus 49, is equal to 25 squared, 625. Well, subtract those values, subtract 49 on each side, and you get GD is equal to 576. Take a square root of each side, and you get 24. Okay, so that's going to be prior knowledge. We'll work more with Pythagorean Theorem in this lesson, but I want to start out by reminding you of the trigonometric ratios, sine, cosine, and tangent. So a trig ratio is a ratio of two sides of a right triangle. And the three primary ratios are sine. Can you say sine? Good. Can you say cosine? And can you say tangent? Awesome. All right. So if I am working with a right triangle, and here is a right triangle, I know it's a right triangle. I know that this angle is 90 degrees because of that little box in the right, in one angle in the corner. If I want to go ahead and find sine, cosine, and tangent, well, I'm going to involve the sides. Now, the sides have specific names relative to an angle, whatever angle you're working with. So here, if I have this point, let's call this point A, right here, this becomes angle A, So the side that's opposite of angle A, directly opposite, if it was looking at it, right, almost like forming it. If you hold out your arms, the side that would be formed between your two fingertips, that would be opposite, okay? The other side, the side that's next to it, that is called adjacent. That is the adjacent side. And then the side that's across from the right angle always is the hypotenuse, okay? So that's just kind of going through labeling the sides and how you determine what the sides are called. Okay, so what we're going to go ahead and do is I'm going to introduce you to the trig functions. And again, the trig functions are sine, cosine, and tangent. And I want you to go ahead and memorize this acronym. SOHCAHTOA. Go ahead and say it with me. SOHCAHTOA. SOHCAHTOA. And SOHCAHTOA is the mnemonic device that can help you remember what sine and cosine and tangent are. Okay, and I'll go ahead and first introduce you to sine. Sine is the side that's opposite over hypotenuse. So sine of the angle A is equal to the ratio of the side opposite and the side that is the hypotenuse. Cosine. Cosine of an angle is the length of the side that is adjacent divided by the length of the hypotenuse. And then lastly, tangent. Tangent of the angle is equal to the ratio of the side that is opposite divided by the side that is adjacent. Now, where does SOHCAHTOA come into play? Well, and I like writing it, I put it right over here, somewhere right here, up on the board. Sine. Sine is the side opposite over hypotenuse. So we say so. Cosine. Cosine is the side that's adjacent over hypotenuse. So, there's the And then lastly, we have tangent. Tangent is the side that is opposite over the side that is adjacent. So there's the TOA. SOHCAHTOA. 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 All right, there's SOHCAHTOA. Let's go ahead and look at an application of it. So for this example, they say, given the right triangle ABC, find the following. And they want sine, cosine, and tangent. Well, the first thing these problems are going to require you to do is to find a missing side. Find the missing side. So this side is across from my right angle. I'll call it little c, right? The side that's formed from that angle is always a lowercase letter of that. So angle C forms that side, so it's little c. And Pythagorean Theorem, again, is a squared plus b squared is equal to c squared. Okay, so in this case, it's going to be 6 squared plus 8 squared is equal to c squared. It doesn't matter which one comes first, 6 or 8. What does matter is that the hypotenuse is always alone on the right side. So I'm going to go ahead and solve this. 36 plus 64 is equal to c squared. We can add those together. We get c squared is equal to 100. And then we'll take a square root of each side. That's how we undo a square. All right? So we get c is equal to plus or minus 10. I'm only going to take the positive value because negative 10 contextually does not make any sense here. So c is equal to 10. Okay, so my hypotenuse is 10. All right, so I want to go ahead and identify what's sine, what's cosine, what's tangent. And they give us a specific angle here. They say A. So first thing you should do is go ahead and draw an arc in that label. So we're right here, angle A. Okay, and then I just want to label my sides. Put a star. Label sides. It's very, very important that you label your sides. So from A, the sides that is opposite is 6. And I would use pencil here. Make sure you're using pencil. If you like taking notes in pen, it's going to get super messy. You're going to need to erase. So I'm just giving you a heads up now. Okay. So the side that's opposite is 6. The side that's adjacent is 8, and I know that that's the adjacent side because 10 is the hypotenuse. Hype? Doesn't this problem get you hyped? Terrible math joke. Sorry. Okay, so now that I've labeled it, I'm going to go ahead and I'm going to find the sine, cosine, and tangent of these values. Okay, so sine. Sine is opposite. Where can I do? Right there. Opposite over hypotenuse. Okay, so the side that is opposite is 6. The side that is hypotenuse is 10. 6 over 10. And we can go ahead and reduce each of these by 2. And this gives us 3/5. 3/5. Okay, cosine. Cosine is adjacent, right by my forehead, adjacent over hypotenuse. Okay, so the side that's adjacent is 8. The side that is hypotenuse is 10. So this is 8 over 10, so 4/5. 4/5. All right, tangent of A. Tangent is opposite over adjacent. TOA. It's this one right here, TOA. Okay, so opposite is 6, adjacent is 8. So 6/8 gives us 3/4. All right, I've done it. I have found sine, cosine, and tangent for angle A. Awesome. Well, these problems want us to also do it for angle B. So what I'm going to go ahead and do, I'm going to erase the hypotenuse. Actually, hypotenuse can stay put, but I need to erase adjacent and opposite because they switch. So here's angle B. Shoop. There's angle B. So now 8 is opposite. 10 stays the same. Hypotenuse is always the same. Always the side across from the right angle. And now 6 is the adjacent. So you notice that those switch sides. And we have to answer these questions. Okay, sine of B. Well, sine is so that's opposite over hypotenuse. Okay, so 8/10, which is 4/5. Cosine, adjacent over hypotenuse. A over H. That's 6/10. That gives us 3/5. And tangent is opposite over adjacent. So 8 over 6. And that equals 4/3. Okay? All right. That's it. Sine, cosine, tangent. SOHCAHTOA. SOHCAHTOA. Label your sides, and then just use the acronym to help you find those ratios. All right. Okay, here is a practice problem. Please pause the video, go ahead and find these values. You're going to have to first, again, find this side here. So I'll pause the video and then I'll actually help you kind of find that here in a second. All right, to help you find x, again, you're going to have to use Pythagorean Theorem. So a squared plus b squared is equal to c squared. So this is the setup that you should have used. 26 must be alone on the side. And then going ahead and solving this, we get x squared is equal to 26 squared minus 24 squared. You should have gotten x is equal to 10 using your calculator. Okay? All right, so now that you know that x, this side, is equal to 10, if you have not already, find the other values. You can pause me again here, and I'll show you the answers here in a second. All right, hopefully you pause the video. Here is the solution. Okay, and you get these values. All right. Next example. Okay, so in this example, again, we want to find sine, cosine, and tangent. I need to find this side, so I'm going to utilize the Pythagorean Theorem. X squared plus 2 squared is equal to 3 squared. And again, I know that 3 is the hypotenuse, so that has to be by itself. Okay, and going ahead and solving this, x squared plus 4 is equal to 9. I can subtract 4 on each side, and we get x squared is equal to 5. Oh, okay, well, when I take a square root of each side, I get x is equal to the square root of 5. Okay, I'm ignoring the negative number because that doesn't make sense contextually. Okay, so this is square root of 5. All right, so they want us to find sine of n. So here is n. Here's n. So this side is opposite. Again, this is hypotenuse. Hypotenuse doesn't change. And then the 2 will be adjacent. So sine is opposite over hypotenuse. Okay, so square root of 5 over hypotenuse, which is 3. Cosine of n is adjacent over hypotenuse, 2/3. And then tangent of n is opposite tangent is opposite over adjacent. So this is square root of 5 over 2. Not too bad, right? Not too bad. Okay, now I'm going to go ahead, I'm going to erase my adjacent and my hypotenuse and then my little arc because I'm going to switch angles. They say, what's the sine of angle P? So here's P. Okay, that makes 2 opposite, and it makes square root of 5 now adjacent. Okay, so sine of P is opposite over hypotenuse. Hey, that's 2/3. And cosine of P is adjacent, square root of 5 over hypotenuse. Okay, and tangent, last but not least, tangent is opposite over adjacent, so 2 over square root of 5. Now something we're going to have to do because we have a square root in the denominator is we have to rationalize the denominator, and I would please write this down. Rationalize the denominator. So I'm going to multiply top and bottom by the square root of 5. So whatever's in the denominator, that's what you multiply by. I'm just multiplying by a ratio of 1. I'm not really changing it, right? Isn't square root of 5 over square root of 5 1? Yes. And when you multiply something by 1, isn't it itself? Yes. Okay. So I just multiply these. So 2 times square root of 5, that gives us 2 root 5. And square root of 5 times square root of 5 gives us square root of 25. And the square root of 25 is just 5. And kind of a quick trick for these, anytime you have a square root times itself, it's just going to be equal to whatever the radicand is, whatever the value that's inside of the root. Okay, so that's just, and that kind of makes sense, right? So there you go. Okay, here is the next example. Please go ahead, pause the video, and try this one. All right, hopefully you pause the video. In this one, you do have to solve for this side, which we can call C, or you can use X. You could use any variable, but this would be 1 squared plus 4 squared is equal to x squared, and you should have gotten 1 plus 16 is equal to x squared, and 17 is equal to x squared. So if we take a square root, x is equal to the square root of 17. So that was that side, okay? So just now that you've checked that, if you have not finished these or need to make revisions, pause the video again and go ahead and try those. All right, hopefully you pause the video. Here are the solutions. And for sine and cosine, if you got this far, if you got 1 for sine of g, 1 over square root of 17, I'm happy with that. It's great if you can go ahead and rationalize to give you square root of 17 over 17. And then same for cosine. Again, we need to rationalize, so you get 4 root 17 over 17. Tangent's nice and easy, 1/4. Hey, isn't that nice? Okay, sine of e, cosine of e. I don't know if you've picked up on this. I'm going to erase this. Have you noticed that whatever sine of one angle is, sine of g, it's going to be the same thing as cosine of e? Ah, there's a shortcut. There's a shortcut. Sine and cosine values of complementary angles are the same. They are the same. And then the same thing here, cosine of g, that's 4 root 17 over 17. Hey, that's the same thing as sine of the other angle, e. And then two, maybe you picked up on this, between the tangent values, these are just reciprocals. 1/4, 4. You just flip them, and that's it. All right. Next example. Here is example number 3. Okay, and again, I have a right triangle that I need to find this side, I'll just call it x for now. So I have x. This side's the hypotenuse. So that side has to be by itself in the Pythagorean theorem. So 3 squared plus 6 squared is equal to x squared. So 9 plus 36 is x squared. So 45 is x squared, and thus x must be equal to the square root of 45. Now, I want to simplify square root of 45. I can break that down. 45 does have a perfect square in it. That's 9 times 5. So I'm doing this, I'm taking out this factorization because it's a perfect square. I can break it down. And the square root of 9 is just 3. So 3 root 5. This side is 3 square root of 5. Okay, so now that I have that side is the square root of, 3 times the square root of 5, I can go ahead, I can find sine, cosine, and tangent. All right, so we're finding sine of angle A. Here's angle A, so this is opposite. This side's adjacent, and we know that 3 root 5 is hypotenuse, always. Sine of A, opposite over hypotenuse. And if you ever get confused, again, just write down SOHCAHTOA. It's a little too close. SOHCAHTOA. Just write it down on your problem. Again, this is the trig function, this is your numerator, and then this is your denominator. So sine opposite, which is 3 over the hypotenuse. So I have 3 root 5. Okay, and I'm going to go ahead and multiply by square root of 5 times square root of 5. I have to rationalize this. So we get 3 root 5 over 3 times 5, which is 15. That is 15. And then I can reduce this. I can cancel by a 3, top and bottom. So actually our answer is square root of 5 over 5. And since I know that the cosine of the other angle is going to be exactly that, square root of 5 over 5. All right, cosine of A. Cosine is adjacent over hypotenuse, so that's going to be 6 over 3 root 5. Again, I need to go ahead and rationalize this. Okay, and we get 6 root 5 divided by 3 times square root of 5 times square root of 5 just gives us, again, 3 root 5, which you can make that 15, but again, I need to go ahead and reduce here. I'm going to reduce the 6 and the 3 by 3, so this becomes 2. This becomes a 1. So I get 2 root 5 over 5. There's your answer. And if cosine of A is 2 root 5 over 5, then sine of B is 2 root 5 over 5. All right, and then lastly, the tangents. Tangent, these ones are going to be simpler because I don't have to deal with that square root. So tangent of A, opposite over adjacent, that's 3 over 6. I can reduce this to 1/2. And then tangent of B, let me go ahead and just switch these. Tangent of B is going to be 6 over 3, which is 2. And again, did you notice these are reciprocals? Reciprocals, you just flip them. Okay, so those are our values. All right, that's the third example. Okay, here is a practice problem. Please go ahead, pause the video, and try this one. I'll go over the side length here of x first. So try that, Pythagorean Theorem, you can check that, and then you can continue through the rest of the problem. All right, hopefully you pause the video. Here is the Pythagorean Theorem set up. X squared plus 5 squared equals 7 squared. So x squared plus 25 is equal to 49. So subtracting 25 on each side, we get x is equal to 24. And then taking the square root of each side, we get x is equal to the square root of 24. Now 24, a perfect square in there is 4. That's 4 times 6. So you can simplify this as 2 square root of 6. You pull out the perfect square of 4. Right? The square root of 4 is 2. So 2 root 6. Okay, so x is 2 root 6. If you have not found sine, cosine, and tangent of angle R, and angle S, then go ahead and do so now. All right, hopefully you found those values. Here are the solutions. And there you go. You did have to rationalize, it looks like, only tangent of S. So that's nice. All right. And then here's one last practice problem. Go ahead, pause the video, and again, I'll go over the Pythagorean Theorem here in a second. All right, here is the Pythagorean Theorem set up. So we have x squared plus 7 squared is equal to 9 squared. Again, 9 is our hypotenuse. So we get x squared plus 49 is equal to 81. We can subtract 49 on each side. We get x squared is equal to, what do we got? 32. Taking a square root of each side, you get x is equal to the square root of 32, which the perfect square in there, this one actually was kind of tricky. 16 times 2. You probably said 8 and 4, but 16 and 2 is fully simplified. So this is 4 root 2. 4 root 2. Okay. Pause the video, find sine, cosine, and tangent of angle P and R if you have not done so already. Okay, here are the solutions. And there you go. Okay. In closure, something that you should have picked up on is the relationship between the sine and the cosine ratio for complementary angles. Go ahead and explain what the relationship between those are. All right, and then here is the solution. The relationship between the sine and the cosine ratios of complementary angles is that they are equal. The sine of G is the same thing as cosine of E here in this example. All right. That was sine, cosine, and tangent. The acronym you need to remember is SOHCAHTOA. SOHCAHTOA right here on the board. That is a great way to remember it. And I hope you learned something. All right, catch you in the next video.